Sound is a longitudinal wave that travels through a medium, so like the air, water, something that's solid, something like that. And what happens, remember, a longitudinal wave goes back and forth. And so what happens is if I speak, the sound goes through the air and into your ears, assuming you're here. In this case, the iPad picks it up. And it causes the vibrations that then are picked up on your eardrum very, very carefully and then decoded in your brain. So you have to have a medium in order for sound to travel. Sound won't travel out in space. There's no air out there, there's no medium for it to travel through. Depending on the medium and depending on the temperature of that medium will depend on how fast the sound travels. So the speed of sound in air at room temperature is about 340 meters per second. In fact, that's what we'll use when we do our calculations. In water though, it's 1,480 meters per second, about there. And steel is 5,940 meters per second. So depending on what the sound is traveling through will depend on what type of speed you'll have with that sound. So we're looking at the equation of V equals F lambda still. And that relationship still holds true. The thing that happens when we're talking about sound is the speed of sound is what we're using for the velocity. So if we're talking about something in air at a given temperature, that velocity stays the same. So when we're talking about sound, we're looking a lot at the relationship between frequency and wavelength. Frequency is still measured in hertz, wavelength is measured in meters. So if the frequency goes up for a sound, it means that the wavelength is going down because the velocity stays constant for that given medium. If your frequency goes down, your wavelength goes up. So I'm talking at a really, really, really high frequency, I have a shorter, teeny tiny wavelength. And if I'm talking at a really low frequency, I have a much longer wavelength. And the range of human hearing is 20 hertz to 20,000 hertz. So if you talk about maybe like a dog whistle, that would be higher than this. In fact, as time goes on, this range starts to narrow and you're not able to hear as much. If we were in class, I'd play that for you and we'd see kind of where people were at. First of all, notice how the speaker is moving in and out. The frequency of the speaker is how many times the speaker moves in and out in a given second. As the frequency is increasing, you can hear the pitch getting higher.